Today we'll begin lesson or unit 5, exponential functions. An exponential function can be described by the equation y equals a to the power of x, where a is greater than 0. But before I go into exponential functions, we'd like to review exponents and powers, because that is a prerequisite for exponential function. So let's go straight there, and the next lesson we will go into exponential function, sketching its graph, etc. So let's look at exponents. Whenever we have an exponent, we have a base. In this case, we have 8 to the power 2. The 8 is referred to the base. 2 as the exponents or the index or power. An exponent of a number says how many times to use that number in a multiplication. So 8 to the power 2, how many times do we multiply 8 by itself? In this case, it would be 2 times, which is 64. For example, also if we said we want 5 to the power 3, the exponent tells me how many times to use the number, how many times I can multiply 5 by itself. So we have 2 to the power 4. It means 2 times 2 times 2 times 2 equals 16. And or 9 to the power 6. So in general, a to the power n tells you how many times to multiply a by itself. So there are n number of those a's. Sometimes people use a symbol on the keyboard as to type power. 2, and you see the symbol here because of the keyboard structure. Now, what happens when you have negative exponents? Recall, is to divide. 8 to the negative 1, this means 1 divided by 8. 8 to the negative 1 is 1 over 8. We have 5 to the negative 3, which is 1 over 5 to the power 3. So in general, an easy way to handle negative exponent is a to the negative n is 1 to the power n. So we take in the reciprocal. Just a quick review of the law of exponents. X to the power 1 is equal to x. For example, you have 6 to the power 1. If x to the power 0 is 1. So anything to the power 0 except for 0 is 1. And we have x to the negative 1 is 1 over x. This applies to the rule. N to the negative 1 is 1 to the power n. Now, x to the power m times x to the power n, as long as we have the base same, it means we add the exponents. So the base, as we referred to the first example here, if the bases are the same, we can add the exponents. We're dividing, and it should be x to the power m, x to the power n. We subtract the exponents. As this example, x to the power 6 minus 2. When we have it in brackets, we multiply the exponents. We x to the power n bracket to the power n. Now, when we have the basis in the bracket, we can expand that and refer to x to the power n times y to the power n. Same would apply to division. If we can write it same as, which is x to the power n, y to the power n. And this refers to our original n to the negative 1. When we have fractional exponent, it becomes the root of the power m. So x m over n becomes the root of, which is the root would be the n, the denominator. An example here, x to the 2/3 becomes the cube root of x to the power 2. And here's a little illustration of how the laws of explained. So we have 5 to the power 2 means 1 times 5 times 5 gives me 25. 5 to the power 1 is 1 times 5 is 5. 5 to the power 0 is equal to 1. 5 to the negative 1 is 1 divided by 5. 5 to the negative 2 is 1 divided by 5 divided by 5. Okay, let's look at some examples. We'll go straight into, and this is one of the activities you need to complete. And it's on the blog. Here, identify the coefficient, the base, and the exponent. The coefficient would be negative 3. So the first one, coefficient, the coefficient is 1, sorry. Coefficient is 1. The base, negative 3x. Exponent, 4. Now, there is a negative 1 in front of here. So if you were to write that, becomes your coefficient, x to the power 5. Coefficient, negative 1. Base x, and the exponent, 5. Coefficient, oh, this would be negative 3 here. One, base, exponent, negative 3. When we're evaluating the expression here, this means 2 by itself. 8 is 2 to the power 4, 3 to the power 4. 2 to the power 4 would be 16. 2 times 2 times 2 times 2. 3 times itself, 4 times. So 3 to the power 4 gives me 81. Six to the power 236. We can simplify this. 3 can go into 36 12 times. We evaluate the expression. We would replace x with 3 and y with 2. So 3 times 2 to the power 3 minus 3 to the power 2. 3 times 2 times itself, 3 times gives me 8 minus 9, 3, it's 24. And that would give me a result of 15. You have b, negative 3, x is 1, square plus 1 times negative 2 to the power 5. We have negative 3 plus negative 2 to the power 5, which is negative 2 negative 2 to the power 5. Now, because it's an odd number multiplication, our rule says that your result should be negative. So we have 3 plus negative 32, negative 35. This is the result. There's a few more examples. Based on our exponential rule, what's in the bracket you multiply outside the bracket. So x to the power 3, and then we have to the outside, so we multiply it, it becomes x to the power 3 times 2, 6. Now, y to the negative 5 plus times 2, result y to negative 10. Now, because it's negative, we can rewrite this as x to the power 6 as a positive exponent. In this case, we have y negative 4, y positive 2. So because the base is the same, you have negative 4 plus 2, y to the negative 2. What is the value of x in the equation? what value multiplied by itself 3 times will give me 125? That would be 5 to the power 3. Now the reverse, what do I multiply? How many times do I multiply 2 by itself to give me 64? Becomes 2 to the power of 6 equals 64. Question 6. Evaluate each expression wrong and answer the 4 decimal places where possible. Because we are multiplying 0.5 to the power 2 times -3, this is 0.5 -6. Now we can write that as 1 over 0.5 to the power 6. This, now we have 2 to the power 3 and 3 to the power 3, and all taken to the power -3. So this becomes 2. If we were to expand this, 3 and 3 to the power -3. So this becomes 9 over 3 to the -9. You can use a calculator to simplify each answer. So if you were to do the first one, -0.5 to -6, which gives me 64. Two to the -9, 2 to the power -9 divided by 3 to the power -9 gives me 38.44. And the final example, seven. We multiply the exponents, so x to the power 3 multiplied by 7 to the power 3. Which results in x to the 21 to the power 3, which is result x to the power 7. The next lesson will be looking at exponential functions and how to sketch exponential functions.